This is a very tedious question, and we don't want to underestimate it. There's a lot going on here. So let's start by writing out that we simply have birch trees and we have maple trees. And we're hearing that there are 6 rows of birch, 5 rows of maple. Each row of birch has 8 trees 20 or taller and 6 trees shorter than 20. So what's happening here is that there are numbers in the names. The question is saying that there are trees that are 20 feet or taller or shorter than 20. Instead of just saying we have tree type A and tree type B, or the way I'm going to want to say it is I'll say we have taller ones and shorter ones. So what's happening is because the names themselves have numbers in them, it just makes the scenario so much tougher to digest. So we have 8 trees that are taller, and this is for the birch. For the birch, we have 8 trees that are taller, and we have 6 trees that are shorter. Now, for the maple, we're being told that there are 9 trees that are taller and 7 trees that are shorter. So these are our numbers of trees. But for the birch trees, we have 6 rows. And let me show you how to apply that. Just going back a tiny bit, when we look right here, we see that for the birch trees, there were 8 trees that were taller per row. So instead of just calling them trees, let's call them trees per row. And that goes for all of these. These are all the number of trees per row. Now, when we see that there are 6 rows of birch trees, well, we have the number of trees per row. If I multiply that by 6 rows, in terms of unit conversions, the rows will cancel, leaving you with 48. So let's just rewrite the chart so we can have more space. Birch, maple, tall, and short. And now we're finding out that there are 8 times 6 trees, 48 trees. And for the birch, there are 6 rows. So here we can say 6 rows. And so when the rows cancel, we have 6 times 6, which is 36 trees. Now going over to the maple, we see that there are 5 rows of maple trees. So 9 trees per row and 5 rows. The rows cancels with the rows, giving you 45 maple trees. And then once again, for the maple, there are 5 rows. And once again, when the rows cancel, we have 7 times 5 trees, 35 trees. So now we've calculated the number of total trees, accounting for the fact that there are this many trees, there are numbers in the names, and there are this many rows. So we put it all together into something that's a little easier to understand. So now we have to deal with the idea of conditional probability. Conditional probability is a really easy idea that a lot of people get wrong. It's the idea that you're only using part of the fraction. So here, when we're being told in this question, given that the tree is 20 feet or taller, given that we're dealing with a taller tree. So in other words, we're only looking at this part of the data. And assuming that we're only looking at that part of the data right there, what is the probability of selecting a maple? So within that purple group, how many of them are maple? 45 of them are maple. So the answer to our conditional probability question is 45 out of the total 93 that we would get from adding 48 and 45. So in other words, as long as we're only dealing with the taller ones, that's 93. How many of those taller ones Our maple, that's the 45. Now we can simplify this, dividing both by 3, and we'd get 15 on the top and 31 on the bottom, and that's why our answer is C.